Welcome to the Modern Application Development Screencast. In this short screencast, we will learn how to add simple indexes to our database. Before we start, open the following applications on your Ubuntu desktop so that you can follow along with me. A browser, preferably Firefox, Chromium is also fine. A text editor, any other IDE, or DB browser, which we have already used before. Currently, I'm going to use the same database that we had used before. I've just added a lot of dummy fake data into a user table for our experimentation. Otherwise, the table structure and the database structure remains the same. So now, what is a database index? A database index is a data structure, which is a lookup that makes it easy to find or locate the specific row that we are searching for without scanning the whole table. Usually, scanning the table takes a lot of time and resources. When you create indexes, you create actually lookups, so it makes it easy for the query planner or the query executor to look for the rows that you're looking quickly using less resources. Let's write a query. So let's write a query to get a row from the user table where username is Thejesh GN and email is I@thejeshgn. It's returning a row. To know how the query is executed, we do something called query planner or query explainer, which actually kind of explains how the query gets executed. You can go to SQLite's explain query plan documentation page to see how it works. Basically, to get the query plan, you just append explain query plan to your query and then run it. So let's run it here. So now you can see it's given a result. You can also see that it's doing a search on the table user using the index SQLite and underscore auto index underscore users underscore 2. Right? So it is actually doing a search on the table, which is good because if you look at the documentation, search actually doesn't scan the whole table. It actually runs on the subset of the whole table, so it makes it faster. But it's using an auto index. Now it's good that it is using auto index, but auto index is also not great because the database actually automatically creates auto index at the runtime, which has its own cost because it keeps creating the indexes when a query is run and then maybe keeps destroying it, etc., etc. So it's always good to use user build, or if we build an index and the database uses that. Let's create an index. Since we are using username and email in the where clause and we are using and, let's create a combined index for these two so that our query uses the index that we have created instead of auto index. Now you can go to create index page of SQLite and get the way to write the query to create the index, which is create index on etc, etc. But you can also create it using UI. Let's create it using UI, so it's much faster and easier. So you can go to create index, select the table that you want to create index on. You can give the name whatever unique name, but I just generally prefer starting with IDX, then the table name, and then the column names that are used in the index. So we are using username and email. So this is going to be our index name. I'm going to mark it as unique because together username and email in our case is going to be unique, right? So we can move that to the right side, and then we can sort them ascending, right? And we can create the index. This will create the IDX underscore user underscore username underscore email index, which is unique. Now marking it unique also has another side effect or a side benefit, where when you are inserting a row, if there is a duplicate of username and email combination, then it will throw an error. So it will also work like a constraint, right? So you need to be careful when you're marking as unique. Okay, our index is created. I'm just going to save it so that it gets saved and created. Now if you go to execute SQL and just run explain again, let's expand this. So you can see that it's just doing search table again, but actually using covering index, which is our own index, right? So this will be any day faster than the query executor using the auto index, because here it's pre-created index and it gets used, and it will be much faster and uses less resources. This is how you create index on a combination of columns. Usually first trying to do query explanation, see how the query is getting executed, and then planning how to write an index to make it faster. That's the process you follow. Now we can create on any other columns or combination of columns or single column. You can mark it as unique or not unique. You can sort it on ascending or descending based on your search plan, how your queries are written. All of those combinations you can try. Now I have not gone into SQLAlchemy here. You can actually go to SQLAlchemy and define the columns as indexable, or you can actually define an index the way we define an index as part of the SQLAlchemy table definition or the model definition. I have not done that here because we are not currently using SQLAlchemy to create tables or alter tables or create index or alter indexes, etc. We are just using them to map and query the tables or insert into the tables or query into the tables. Actually the data, not the schema itself. In future, we are going to use DB migration using SQLAlchemy and Alembic, where we can sync between SQLAlchemy model or schema definition and actual database, either by running the migration or auto migrations, etc. When we come to that screencast, or when we come to that chapter, we will look into how we do the same index creation using SQLAlchemy, and how do we sync it to the database, either by writing a migration or automatic sync. Until then, thank you for watching. Keep using indexes. Thank you. Bye.